Dear students, welcome to this video. Today we will be discussing differentiation. So let us start this topic today with introduction of this topic, introduction of differentiation. Introduction. Let y is equal to fx be a given function. Here x is independent variable and y is dependent variable. I mean, value of y depends upon value of x. So if there will be any change, any increment in the value of x, there will be a corresponding change in the value of y also. And differentiation is defined as a rate of change of dependent variable with respect to independent variable. I mean, rate of change of y with respect to x is called derivative of y with respect to x. Let us try to understand it. Here y is equal to fx be a given function. Let delta x be a small change in value of x and delta y with a corresponding change in the value of y. So we can write y plus delta y is equal to f x plus delta x. You write this equation 1 and this is equation 2. Here we will try to find out the rate of change of y. So first of all, let us find change in the value of y. So how we will get change in the value of y? By differentiating relation 1 from relation 2. So your left hand side you will get y plus delta y minus y by differentiating these two equations. Relation 2 minus relation 1 gives us in left hand side y plus delta y minus y. Accordingly, in the right hand side we will get here x plus delta x minus fx. Here this y will be cancelled out. So delta y is change in y and we have to find out rate of change. Means we will divide delta y by delta x. So therefore, dividing both sides by delta x, we are getting here f of x plus delta x minus f of x divided by delta x. Now derivative of y with respect to x, which is denoted as d dx of y, this is equal to limit of delta y by delta x when delta x tends to 0. So we have to consider here rate of change for very small change, approximately equal to 0. So we will get here limit in right hand side also, limit delta x tends to 0, f of x plus delta x minus f of x by delta x. So this value gives us the derivative of y with respect to x, which is denoted as d dx of y. Sometimes we write it as dy by dx also or by f dash x also. If we find the derivative of y with respect to x at any particular value of x, suppose x is equal to a, we find out derivative of y at x is equal to a, then we will write here f dash a. So you have to remember this expression. This gives us derivative of y with respect to x. And let's try to understand it geometrically. Geometrically, what is the meaning of derivative of y with respect to x? So we'll try to understand here geometrically. meaning of derivative of y with respect to x. Here, this is the axis system, x-axis, and this is y-axis. And y is equal to fx can be represented geometrically with the help of a curve. Suppose this is a curve for y is equal to fx. Let us take 2 points here along this curve, point P and point Q. Suppose point P is having x coordinate A, so corresponding y coordinate will be FA. And coordinates of Q are here A plus H and F A plus H. Here PQ is a chord joining these 2 points P and Q. So geometrically, here derivative of y with respect to x means slope of this tangent PQ. It means slope of PQ when Q tends to P. If gradually Q tends to P, then there is a situation when this chord PQ will coincide with the tangent at P. And finally we will see that derivative of y will be slope of the tangent. This angle makes theta with positive direction of x-axis. So here derivative of y with respect to x is defined as limit of difference in y coordinates, means fa plus h minus fa divided by h. Or you can write a plus h minus a. Finally a will be cancelled out. When q tends to p, you can write here h tends to 0. This quantity h is very small when q coincides with p. So this expression gives geometrical significance of derivative of y with respect to x. So limit f of a plus h minus f of a divided by h, and h tends to 0. This is derivative of y with respect to x, and this is nothing but slope of the tangent at x is equal to a. X is equal to a means this point P. So this derivative can be written as f dash a also, or we can write derivative of y with respect to x at x is equal to a. So that's all about introduction of differentiation of a function, geometrical expression also, geometrical significance just now we have seen. And in the next video we will see to get derivative from first principle. So getting the derivative with the help of definition, I mean this is the definition, rate of change of y with respect to x. This is definition of differentiation. So getting derivative with the help of definition of the differentiation or derivative is known as to get derivative from first principle. So dear students, we will see this in the next video. I hope you might have got the benefit from this video about introduction of differentiation. I hope you will watch my video continuously to get maximum benefit in the topic of differentiation. So please give a like to this video and subscribe my channel Anand Misra and please share it with your friends also so that they could get benefit from these videos. Thank you very much.